Hi, I'm Mrs. Ferguson, and I'm going to show you how to do number 6 in the Chapter 1 closure packet. I'm going to be doing all 6 parts, A through F, so feel free to fast forward if there's a certain part that you need to see. So with part A, we have 2 divided by the absolute value of 3 minus 4. Absolute value bars are kind of like parentheses, so we want to actually evaluate what's inside them first. So we're going to start by figuring out what is 3 minus 4. And we know 3 minus 4 is negative 1. So we make that the absolute value of negative 1. Now we're going to evaluate the absolute value of negative 1. Absolute value bars make everything positive. So we know the absolute value of negative 1 is just 1. And then finally, we're going to do the division. So 2 divided by 1 is 2. 2 is going to be our final answer. So for B, we have absolute value bars with just a negative 6 inside them. So we can go ahead and evaluate what the absolute value of negative 6 is. Again, absolute value makes everything positive. So the absolute value of negative 6 is positive 6. So that's going to become just a 6. We still have our 11 out here. What should we put in between them? The 11 was just right next to the absolute value bars. In math, when things are right next to each other, it just means we're going to multiply. So I'm going to put a dot to show that that's multiplication. And then we still have the plus 15. And then we want to think about PEMDAS. So we know we're going to multiply before we would add. So 11 times 6 is 66. And then adding is our last step. 66 plus 15 is, let's see, 81, I believe. So that one's 81. So moving on to part C. So for part C, we have negative 19 plus the third root, which we call the cube root of negative 8. We need to evaluate the root before we do the adding. Roots are kind of like exponents. So if you think about PEMDAS, the E is for exponent. Roots are actually a part of that too. They go along with exponents. So the cube root of negative 8, that would be a number that we can raise to the third power and get negative 8. So a number that we can multiply by itself 3 times and end up with negative 8. And there is a number that does that. I'll kind of show you down here. It's actually the number negative 2, because negative 2 to the third power would be negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4, but then when we multiply by this last negative 2, we're finally going to end up with negative 8. So negative 2 is the cube root of negative 8. So that's what we will replace that with up here, is a negative 2. And then we're just adding. We have negative 19, and we're adding negative 2 to it. When we add negatives, we just get more negative. We get a bigger negative. So negative 19 and negative 2 together would be a total of negative 21. So then for part D, we have negative 11 minus the square root of 16. So again, roots are like exponents when we think about PEMDAS, so we want to evaluate the root before we do anything else. The square root of 16 is a number that when you multiply it by itself, you get 16, and that's 4. And then negative 11 minus 4. So let's think about that. Negative 11, so that's 11 units below 0. And then we're going to subtract 4. So subtracting is going to make it more negative, make it go further below 0, and put us at negative 15 as our final answer. And then we have part E. So for this one, we have the absolute value of 8 minus 11, and then we're going to subtract 6 from that. So again, absolute values are kind of like parentheses. We want to first evaluate what's inside of them. So 8 minus 11 would be negative 3. So inside the absolute value now, we just made it a negative 3. Then we're going to take the absolute value of negative 3, which would be positive 3. And then we still have this minus 6. And finally, we're going to do our subtraction. 3 minus 6 is negative 3. So that's our final answer for that one. And then F, we have the square root of 9 and then it's right next to these absolute value bars. So it's being multiplied by the absolute value of negative 3 times 8. So again, absolute value bars are kind of like parentheses. We want to evaluate what's in here first. So I'm going to rewrite my square root of 9. I still have the absolute value bars, but I'm going to simplify what's inside. So negative 3 times 8, a negative times a positive is always going to give us a negative. And we know 3 times 8 is 24. Now we can evaluate what the absolute value of negative 24 is, and that's positive 24. The square root of 9 is 3, because 3 times 3 is 9. And then again, since these were right next to each other, that means we're multiplying, so we put the dot in between. And then our last step is to multiply 3 by 24, which I believe is going to give us 72.